Namaste. Welcome to Dr.ARM's chemistry. We were discussing the theory of acids and bases, in which we are now considering the strength of acids and bases. So under this title we have seen various factors which are affecting the magnitude of the acid and base strength. And today we will discuss the next point that will affect the strength of acid and base, and it is solvation. Solvation is a process in which we are adding some solute to the solvent. Any suitable solvent can be used, and we can consider whether it is soluble in the solvent or not. So this will solubility also is associated with the solvation energy, which determines whether the acid is stronger or weaker. Normally, when we are considering the amines, so amines are, these are the amines which are derivatives, alkyl or aryl derivatives of ammonia. And when we replace the hydrogens by alkyl groups, we can obtain such Me2NH, that is dimethylamine, methylamine, trimethylamine, and this is ammonia. So we can get such series of amines, and this order of these amines indicates that which acid or which base is stronger or weaker. So this gives the basicity order in aqueous solution. So this order shows that Me2NH is strongest base in this series. Next to it is MENH2. Next is Me3N, and next is NH3. So this strength is also considered in terms of the pKb values. So these values are shown here. So Me2NH has 3.23, the lowest value of all these. Then MENH2 is slightly higher value. Means compared to this is relatively weaker base. So the basic strength is slightly less. Again, if we go to Me3N, it is 4.20, means it is again weaker than this MENH2, and NH3 is the weakest base. Similarly, if we take another series in which the ethyl is substituted, so these are ethyl substituted amines. So first and strongest base is diethylamine. Then, so this is stronger than ethylamine. This is equal to triethylamine, and this is a stronger base than NH3. So here, if we observe the substitution of these hydrogens of ammonia by alkyl groups, then we understand that every methyl or ethyl group attached to this nitrogen is electron donating. So it donates electron cloud towards nitrogen, and as a result of this, nitrogen becomes more electron rich. So this electron cloud is increasing with number of alkyl substituents. So here the number of alkyl substituents are 2. So the electron clouds, the electron density on nitrogen is more. So this is more capable, most capable to share its electron with proton. Here it is methylamine. So relatively the number of methyl groups are less, and therefore it is relatively weaker base. So basicity is relatively less. Again here you will find that there are 3 methyl groups, even though it is weaker base than all these 3. Why it is so? So this is interesting question. So in this case also, the diethylamine is strongest base than these 2, ethylamine and triethylamine, and ammonia is weakest base. So this is considered in terms of solvation. So such change or unexpected behavior of these amines, especially triethylamine, which is expected to be the strongest base, but here it is weaker than its primary and secondary amines. So this is attributed to the solvation effect, so which we are studying here. So the solvation effect depends upon the number of protons which are attached or available with this nitrogen, to form hydrogen bonds when the amines are dissolved in water. So here in this case you will find that there is one proton available for protonation when it is dissolved in water. Here you are having two protons available for protonation, means formation of hydrogen bond with water. This is equivalent to this, but in this case you will find that there is no hydrogen, and that is why these are weaker bases. Both are equivalent, and nitrogen has 3 hydrogens available for bond formation. So this is explained here. This is general formula of the protonated base. Protonated base means when the base is dissolved in water, the proton of water is showing attachment or hydrogen bond formation like this. So nitrogen gets hydrogen bonded with the water molecule like this. So we will get, means this is in gaseous state, but when it is dissolved in water, it gives this protonated aqueous solution, in which these amines, these are considered as R, alkyl groups. So RNH3, this is protonated primary amine, is having solvation energy very high. So this has more solvation, maximum solvation energy, because it has the more number of protons for formation of hydrogen bond with water. In this case, relatively, the number of protons available for bond formation with water are less or few. Here, the nitrogen has no proton because this is protonated species. So there is no bond formation, means it is less soluble. And in this way, we can say that the triethylamine, even though there are 3 electron donating species attached to nitrogen, or in this case here will be 3 NH. So these are expected to be stronger base. So basicity order is expected to be very high here. But unexpectedly, due to solvation effect, these are weaker bases. So with this, we will stop our discussion here and we can go to the next point in the next lecture. So till then, goodbye. Please subscribe to this channel, and you can put your comments in the comment box or dialog box. Please press bell icon and like button. So thank you very much for watching this video.